Now I would like to invite Arpini Hovhannisyan. I'm very sorry if I wrongly pronounced your name. Would you please pronounce your name again? She's going to present us impact of domestic wastewater on surface water quality in some residential settlements of Armenia. Then she is not leaving us. She will continue with water quality assessment based on background concentrations of hydrochemical parameters in the Akuryan River Basin, Armenia. Thank you.
Okay, thank you too. I'm Arpine Hovhannisyan. I'm going to present two study works. The first one is my colleague's work. She unfortunately could not be here today. Because of it, I will do it instead of her. So, impact of domestic wastewater on surface water quality in some residential settlements of Armenia. After domestic supply, the water resources are saturated with additional substances or energy forms that directly or indirectly alter the nature of water body in such a manner that negatively affects its legitimate uses. The natural water resources have a buffering capacity, thus can neutralize the negative effects of these substances depending on their type and amount. Therefore, in some cases, additional artificial treatment of domestic wastewater is needed. So, one of the main environmental issues of sustainable wastewater management is to identify in which case the water body can neutralize the impact of wastewater itself and when the wastewater needed to be treated. For this purpose, the assessment of domestic wastewater's impact on water quality for some residential settlements on the Marmarik and Zahkazor rivers was conducted. The main aim of this study work is to investigate the domestic wastewater impacts on water quality of the rivers depending on seasonal and human activity periods. The preliminary investigation showed that during tourist season, the population number in settlements increased in several times, which leads to highly increase of domestic wastewater discharged directly or diffused into the rivers. So the studied rivers are the tributaries of Hrazdan River, which is one of the major rivers in Armenia. The river basins are the likely places for family rest and recreation zone. The main environmental issue for these regions is domestic wastewater discharge. There are not any operational wastewater treatment plants in the settlements. Moreover, the sewage system in the small villages is absent at all. The domestic wastewater of settlements in region is directly released into the environment, commonly in the Marmarik and Zahkazor rivers. The statistical data showed that the human activity period for Marmarik River Basin is summer holiday time, when usually from June to October the population number is rising up to 5.6 times, and for Zahkazor River Basin is winter season, snowing time, when from November to April the population number is rising up to 7 times. The water quality investigation for the rivers were took place in the observation points on Zahkazor and Marmarik rivers, which is mentioned on the slide. The hydrochemical observation was performed in the sampling points for several parameters. The water sampling and analysis implemented for mainly all months period during 08 till 14 according by ISO standards. The impact of sewage on river water was conditionally considered as a point pressure for the study rivers, and the assessment of the impact was conducted based on the number of population. According to EU Urban Wastewater Treatment Directive, urban wastewater entering collecting systems shall before discharge be subject to appropriate treatment. Primary and or secondary, she means biological, I think. When the population equivalent for agglomerations more than 2,000 In this case, she suggests biological treatment. For the settlements which population equivalent less than 300, sewage systems are not required. When the population equivalent in agglomeration of settlements is between 2,000 and 10,000, before discharging to the freshwater, the urban wastewater only required to be primarily treated. For the other case, the secondary treatment is also needed. Taking into account there are not any operating industries in the observed settlements, so the population equivalent was considered as an equal to population number. From the observed settlements, only Hankavan village does not need existence of sewage system. The domestic wastewater can discharge in septic pits, which will not have significant impact on water resources. But during human activity in the summer, the population is increased up to 800 people, which is more than acceptable. The Zakhkadzor town and also in Aghavnadzor and Meghrazor villages should have centralized sewerage system. Also, the domestic wastewater has to be primarily treated before discharging into the rivers. For the Aghavnadzor village, during human high activity period, tourist season, the population number in agglomeration increases up to 10,000, which requires the secondary treatment of wastewater before discharging into fresh water. So, based on wastewater discharge impact assessment method by Novotny, the concentration of pollutants penetrate into the river flow through water discharge was calculated. The calculation results showed that Zakhkadzor town's domestic wastewater discharge had the highest impact on the water quality of Zakhkadzor river in tourist season. The reason lies in the small river flow of the river and high amount of untreated wastewater discharge. So Zakhkadzor town is viewed as potential source of significant pressures for the river. Due to relatively high river flow of Marmarik River, the self-purification processes are active in the aquatic ecosystem, hence the impacts of domestic wastewater on the river reduces easily. In the study work also, the water quality assessment of Zakhkadzor and Marmarik rivers by hydrochemical parameters were done. The study results showed that the actual pollution is higher than the projected one in all cases. The differences is the most obvious in Marmarik River. During tourist season in Marmarik River downstream, the actual increase for the concentrations of ammonium nitrogen, which was up to 100 and more times. For suspended solids was 2 times about. For COD was 1.3 times higher when wet in the non-tourist season. During tourist season, due to the increase of domestic wastewater discharge of Zakhkadzor town into the river, in the river water of downstream the town, the actual increase for the concentration of ammonium nitrogen was 1.5 times. For COD was about 4 times higher than in non-tourist season. For the other pollutants, the actual increase of concentration had not been significant. In the aims of assessment of sewage water's flow affecting the water quality of Zakhkadzor and Marmarik rivers, the classification of water quality by ecological norms was performed. According to the results, the conducted analysis, the water quality in upper rivers of Marmarik and Zakhkadzor were characterized basically as of excellent and good ecological status in both mentioned periods. After discharge of domestic wastewaters of settlements into the rivers, the water quality of the rivers corresponded to bad ecological status mainly due to orthophosphates. In the case of Zakhkadzor river, also ammonium nitrogen. So the results showed that the concentration of other nutrients also increased, such as nitrates, and total phosphorus. These increased values are more visible in the active tourist season, when the concentration of these nutrients increased in the Marmarik River by about 2 times and the Zakhkadzor River by 5 times, against their concentrations during the non-touristic season. So, and in this slide, you can see the conclusions of this study work. I have to read, or it's visible for everybody? Okay, due to small population in the villages of Marmarik River Basin and in Zahkazor town of Zahkazor River Basin, the domestic wastewater discharge is small and the impact on the water quality of the rivers is offset by the self-purification capacity of the rivers. Since 2010, because not sustainable tourism development, the water quality of the Zahkazor River reduced from moderate to bad water quality class. The concentrations of nutrients are continuously increasing on water of the river, which has led to slow the self-purification processes in the river. The Marmarik River is more protected than Zarapur River. Thank you for your attention.
Thank you. Any questions? I don't know. You can continue with the second one.
Okay. So, the title of my study work is Water Quality Assessment based on background concentrations of hydrochemical parameters in Ahurian River Basin. Let me start and say a couple of words about water quality assessment system in my country. So, in the assessment of the quality of surface water, the typical procedure is that the concentration of contaminants of the surface water is monitored and subsequently compared with their respective maximum permissible concentrations, MPCs. If the MPCs are not exceeded, then the water quality is considered to be safe. But can we be certain that this is true? In Armenia, previous system of surface water quality assessment was based on the MPCs for fishery inherited from former USSR. The application of MPCs in Armenia is highly disputable. The same value of MPC of certain chemical indicator used for the water objects of different geographical zones. The MPC did not provide any information about the pressure on the water object. So monitoring programs produce an enormous amount of information that is difficult to grasp. In this situation, development of site-specific water quality objectives is warranted. Site-specific objectives are derived for individual watersheds, which take into account natural background conditions and management targets. The targets of this study is the calculation of background concentrations, the application of background concentrations in derivation of water quality assessment system, the assessment of water quality of Ahurian River and its tributaries, and the determination of pollutants and their pressures. So in this slide, it is shown the study area, Ahurian River Basin, which is located in the western part of Armenia. In the middle and lower reaches, Ahurian River is transboundary with Turkey. In Armenia, the Karkachun and Ashotsk are the observed largest tributaries of Ahurian River. In this river basin, the agriculture is one of the leading branches of economy. And in this river basin, all wastewaters, including communal, industrial, and non-industrial, are discharged into the rivers without treatment. For our observation, the dataset originates from 5 sampling sites along the main flow of Ahurian River, 2 sampling sites along the flow of tributary Ashotsk, and 1 sampling site of tributary Karkachun. The sampling sites are located in representative sites where specific water properties are controlled. Let me go back to the calculation of backgrounds. So for the calculation, first of all, for the assessment of background concentrations of hydrochemical parameters, the location with natural or minimal anthropogenic influence where water quality data are available was chosen. From the existing monitoring sites in Ahuryan River Basin, the source of Ashotsk River was selected. It was the number 36. So, since in nature processes mainly are described by normal distribution function, the determination of background concentrations was carried out using the function of log normal probability distribution. And for the simplification of calculations of background concentrations, a special computer program was written, and in this slide you can see the external look of software for calculating the background concentrations. Here are the sequence of steps in the implementation of the calculation of percentile. The first step is choosing the location with natural or minimal anthropogenic influence. It was Ashotsk River source. For the calculation, we use data from 06 to 9. And for this data, we make some statistical calculations. And as for the estimation of background concentration values was done from the log normal probability curve as percentile, where sudden concentration horizon appeared. And in the next slide, you can see the specific example of calculation of background concentration of copper. In this case, the background concentration was estimated as 50 percentile. So, for Ahuryan River Basin, site-specific water quality assessment system has been developed with application of calculated background concentrations. The evaluation system has been developed taking into account the EU Water Framework Directive approaches. Classification scheme for some indicators is given in the first table, you can see. The surface water quality evaluation system for each hydrochemical quality indicator differentiates 5 classes: excellent, first class; good, second class; moderate, third; poor, fourth; and the bad, fifth class. The overall status of water quality is formed by chemical indicator showing the worst quality class. Presented water quality classification system is based on the idea one out, all out. It means that if any parameter is classified bad, then the water quality is bad. The contaminant concentrations corresponding to quality class first characterize the water condition as free from anthropogenic impairments. The most stringent water quality target were for the protected asset, aquatic communities, and fishing is defined by quality class 2, which therefore constitutes the aspired good water quality. Water body corresponding to subsequent classes 3, 4, quality class moderate and poor, can be used for irrigation and hydropowers. So this is the final results for the water quality assessment in this river basin. For the classification of water quality in each sampling site of Ahuryan River Basin, the concentration values of hydrochemical indicators were compared with water quality assessment objectives derived for this basin. The common repetitive tasks were automated using some macro in Excel software. So, according to the results in upper reaches of Ahuryan River, the water quality corresponds to moderate and poor classes due to phosphates. In this section, the water has high potential for self-purification due to its rapid turbulent flow. which ensures the saturation of river water by oxygen, whilst lowering the impacts of anthropogenic pressures from communal wastewaters and return flows from agriculture. The quality of water in Ahuryan River worsens considerably downstream Gyumri because of inflow of untreated domestic, agricultural and cattle breeding wastewaters of settlements of the catchment area. The water quality in the section downstream Gyumri is assessed as bad. Water quality is bad in Karkachun River also, where the sewage water of some large towns is discharged. In the upper sections of the Ashotsk tributary, the water quality is characterized by good status. In the lower sections, it was moderate, third class. So at the same time, water quality was assessed by using the MPCs also. Comparison with MPCs has been shown that already in the first site, without anthropogenic influence, concentration of some metals such as copper and aluminum exceeds corresponding MPCs, but shows there is hardly any correlation between an exceedance of an MPC and detection of pollution sources. List of pollutants detected by using MPCs is substantially different from the list obtained from the classification based on background concentration and does not reflect the actual pollution sources and types of pollutants. So, the conclusions of this study work. So, the application of log-normal probability functions on the hydrochemical parameters concentrations has been able to estimate the background values of hydrochemical parameters. The background concentration-based system is an effective tool for the assessment of surface water quality, evaluation of pollution, and the real impact on water quality for Ahuryan River Basin. List of pollutants detected by using MPCs is different from the list obtained from classification based on background concentrations and could not reflect the type of pollutants. The water quality is characterized by bad status in Ahuryan River downstream Gyumri city and in estuary of Karkachun River. And the last one, in Ahuryan River Basin, sewage and communal wastewaters from the settlements are the key factors of significant impact on water resources quality. The main pollutants in Ahuryan River Basin are nutrients. That is all. Thank you for your kind attention.
Thank you. Any questions? Alan, maybe you can use this.
Yeah.
This one?
Yeah. Thank you. The parameters exceeding MPC, that column. You show that the metals are higher than they should be. Any explanation as to why? Because this is not a mining area. This is not a...
No, this is not a mining area. Maybe it can be explained by the geochemistry of that area. Actually, in the near the estuary of Ashotsk River, there are the deposit ores, which are not explored any time.
Thanks.
Any questions?
The clarification, you said these copper concentrations are quite high. There should be hydrothermal copper deposits which could be leached away, so copper could go to solution and then go to the waters. It seems to be the likely case, but have you investigated following the question of the previous gentleman? Because our deposits do not have such high concentrations of copper. Even in conglomerates, the concentration of copper is parts per million. It's not that high.
Thank you for your question, but if I say that we have the exceedance from the MPC of copper, it was about the source of Ashosk River. That part is very clear, there is not anthropogenic pressures, and the depositors are near to estuary of that river.
Thank you. I think there is no question left. No. I would like to close this session because the other two presentations are not here. Presenters are not here. Thank you for listening us, and thank you for the distinguished presenters. And enjoy your rest of the day, please. Do you want to say anything?
So a goodbye from me as well, and thank you for all coming. And I would like to point that provided that we saw that there are quite a few common issues from nitrogen, nitrates, phosphorus, high concentration, eutrophication, which was presented for the Ukraine Odessa side, down to problems with to Armenia with high concentrations of again. There should be some cooperation of all these projects, some kind of capitalization projects, so that you could exchange ideas and see how you can influence each other, and also incorporate, if possible, the results and the methodologies which have been employed in other projects to solve particular problems in your area. This is something which is quite, I would say, highly supported in European Union, all these capitalization projects which could bring out, which could combine all bilateral projects into one project and have a more solid and integrated approach in solving problems in such high scale, broader areas like the Black Sea Basin. Thank you once again.